not the sharpest pencil in school.
Unit 3, functions, day 2. Yesterday, we knew a function, and then I threw out lots of words that we didn't know right away. I said it was a relation between inputs and outputs, where every input value had to have its own distinct output value. Then we learned that input values were our x values, our outputs were our y values. We then learned the most important thing about functions so far. Is it a function? What has to happen for it to be a function? Hands up. What has to happen for it to be a function? Grego.
All the x-axes have to be the same.
Good. Let's not say
all
x.
different.
All different. Let's call it not axes, but values. The x-axis is just a line. Okay, so we're going to say to be, or not to be a function. Every single x value must be different. Okay? Every single x value must be different. Everybody with me? Yesterday, and again, we're just going to do a nice quick one. I gave you ordered pairs. 3, 1, 1, 3, negative 3, 1. And I could say, is this a function? Greg.
Yes, it's a function. You say because?
Yep.
Because all the x values are different.
Very good. Great word. Yes, it is a function because this is xy, xy, xy. To be a function, all of the x values must be different. So yes, it is a function. That was in ordered pairs. Okay? Remember when I said the relations? This is a relation. This is a relation. This is a relation. The ordered pairs are the relation. The group together is what we're looking at. Okay? We are going to do something a little bit different. The same process holds true. All of the x values must be different. There's ordered pairs. What did we call this yesterday?
T-chart.
A t-chart. Very good, guys. This is a t-chart. If I give you a t-chart and say, is this a function? I see some heads already shaking yes. I see some heads shaking no. Okay, Haley. Redeem yourself,
I
honey.
think I got it this time. No, it's not a function because there are 2 1s in the x value.
Okay. Again, that's fantastic, Haley. Fantastic. To be a function, every single x value must be different. We talked about t-charts yesterday. Even though they're not written as ordered pairs, are they still ordered pairs? Yeah. This is an ordered pair that says 0, 7. Did I start the camera? Oh, shoot. Because we were going to start over. If that camera wasn't started, we were starting over. So this is an ordered pair, 0, 7. This is an ordered pair, 1, 4, 2, 4, 3, 4, 1, 9. Haley, one more time. Why do you think it is not a function?
Because there are 2 1s in the x value, and when there's a number repeated, it can't be a function.
Only the x values matter. So 0, 1, 2, 3. If I stopped it right there, is that a function? Absolutely. But because there are this one and this one, it is not a function. Does it matter that these 4s are repeating?
No.
The y values do not matter. Isabel. What do you mean when we don't count the y's? So for it to be a function, and once we start graphing, you'll see it a little bit, it has to have a distinct y value. So 1 has its own y value of 4. Okay? Y's can repeat as many times as we want because the graph will still work. But as soon as we start graphing with 2 1s, it's going to overlap and repeat itself, and then it's going to hit twice, and it's not going to look pretty. And I promise you, as soon as we start graphing, which we'll do today, you'll see what I mean. Okay? So, we said this was not a function.
I think I understand that.
So, right now, we have two ways to take a look at functions. Ordered pairs, t-charts. Trouble so far? This, I feel like, is the toughest. A mapping diagram. Okay? A mapping diagram. It will still always go X, Y. This is like a T-chart. But instead of having a chart, we've got bubbles. Truly, we've got bubbles. In my X, I'm going to put 1, 2, 3. In my Y, I'm going to put 4. To have a mapping diagram, you must have bubbles and arrows. And right now you're probably looking at this going, ooh, bless you. You're not probably looking at this going, bless you. But you're probably looking at this saying, don't know what that means. If I tell you this mapping diagram really shows 3 ordered pairs. Brooklyn?
Wouldn't it just be 1, 4, and 2, 4, and 4?
It would, Brooklyn. It would be 1, 4, 2, 4, 3, 4. That's what this is saying. Notice how there's one arrow coming off of 1, which is in the X place. One arrow coming off the 2, which is in the X value. One arrow coming off the 3. Is this a function?
Yeah.
I know it is a function because there's only one arrow coming off of each X value. So yes, it is a function. If you can't look at this and say, oh, I know that's a function, guess what you can do? Write it as ordered pairs. If I write it as ordered pairs, are all of my X values different? Absolutely. Can we try another one? So again, mapping diagram. X, Y, 1, 2, 3, 4, 5, 6, 7. Is it a function, yes or no, and why? Is it a function, yes or no, and why? Let's give everybody a chance. Let's give everybody a chance. Okay, Brendan. And you've been impressing me the past couple days. Really, I want you to know that. You've been impressing me. Is it a function, yes or no, and why?
It's not a function because there's 2 lines coming from both of you, which means it's going to just repeat.
Very good, Brendan. Did everybody hear that? Brendan spoke mathematics beautifully. He said, no, it is not a function. Why? There are 2 lines coming from the 3, which means how many ordered pairs will have an X value of 3? Show me with your fingers. Show me with your fingers. Yeah, everybody's got 2 fingers because the ordered pairs would be 3, 6 and 3, 7. If there's 2 arrows coming from the X side, will it be an ordered pair? No, wait, let me try this again. Will it be an ordered pair? Yes. Will it be a function? No. So, Brennan, fantastic, my man. No, it is not a function. Do we need to see any more mapping diagrams? Do we need to see any more T-charts? Okay. Last thing that we need to see. And it goes back to Isabella saying, hey, Mr. H, why? Why does it matter that the x's have to be different? Well, for it to be a function, we said the x's all have to be different. We don't care about the y's. We want pretty graphs. And you're going to understand in a second what I mean by pretty graphs. One, two, three, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay? So there's my coordinate plane. I would draw a coordinate plane. I would make sure that it has 4 dashes on each little spot. So, here's what I'm going to do. You're going to see something that looks like this. Bless you. And the question is going to be, is it a function? For it to be a function, what do we know has to happen? What has to happen? Haley. All the x values have to be different. This x, this point right here, is negative 4, 1. Does everybody agree with that? This one is negative 3, 1. Negative 2, 1. Negative 1, 1. And we could keep on going. Graph looks pretty. Okay? It's not jumbled up. It's not coming onto itself. We want a pretty graph. To check when it's a graph, it is called the vertical line test. Vertical means which direction? Left and right or up and down?
Up and down.
Up and down. I'm going to get a different color. So we've got my coordinate grid in black. We've got our graph in red. What I'm going to do is I'm going to draw a vertical line straight up and down. How many times does it intersect my red line? Once. That means there's only one x value. How many times? You're going to have to do this at a couple different places. How many times does it intersect my x or my graph? Just once at each vertical line. So I would say, is that a function? Yes. Yes, it is a function. Well, what wouldn't look like a function? So, same thing. Ready? So there's my graph. So let's start with our vertical line test. If I draw my vertical line, it intersects once. Does that work? Yeah, that's great. How about over here? Intersects once. So far, so good. Is it going to always work like that?
No.
As soon as I draw this line here, once, twice, 3 times. As soon as it intersects more than once, how many x values do I have right there? I would have 3 of the same x values. So this is not a function. For it to be a function, we're really looking at quadratics, which are parabolas. We're looking at cubics, which don't overlap. We're looking at linear functions, which are straight lines. Okay, the reason why I haven't been saying so much about the y's is because Tomorrow when we actually start to graph and substitute in, you're going to learn some of these words. Right now we don't know what parabola and that kind of stuff is. Okay, does that make sense?
Mhm.
All you have to do is the vertical line test, which means draw lines up and down. If it intersects more than once, is it a function? Nope. That's it, folks. I mean, really, we've done 4 things now. Ordered pairs, all the x's have to be different. T-chart, all the x's have to be different. Mapping, we can't have more than one arrow coming from an x. And a graph, where it has to pass the vertical line test. To pass the vertical line test, it cannot intersect more than once. Again, this passes because it intersects once. Everybody with me? Questions? Is this hard?
Yes.
No.
Well,